Hey everybody, how'd you like seeing my hair there? Checking what page I'm on. I'm on page 270. So, solve a direct proportion problem from a table. So, the number of peaches sold, P, is directly proportional to the number of crates used to pack them, which is C. And then they say use this table of information to help find the constant, the equation, and then the missing values. So of course it doesn't say find out if it's a direct proportion, directly proportional relationship or not, because it tells you right there that they are directly proportional. So you want to look for that phrase, right? Once you find out they're directly proportional, the term before that is your pause. You're coming back. This is your Y term. So the number of peaches is your Y term. And then your X term is the number of crates. And of course, this is true because we know that in a table, the Y is listed below the X term. So I might, and what did I need here? Number of crates. So number of peaches. So I need a P here. Sorry. This is our P, all right? So, but just to like kind of organize my thinking, I can just be like, yep, I know this is my X, which makes sense. It comes after directly proportional. Crates is my X, and number of peaches sold is my Y, okay? So the first thing it asks us to do is find our K, our constant. So this is the only one where we're offered both, right? I can't use this one because I don't have an X term, and I can't use this one because I don't have a Y term. So I'm gonna go ahead and use this one, which is 600 divided by 15, which means that our constant is 600, 600 divided by 15 is 40. So what does our constant represent? So our constant represents that there are 40 peaches per crate, okay? And if I wasn't sure of that, I can double check and say, is that really what it means? Well, what's 40 per crate? And if I have 15 crates, hopefully it's 600. Ah, it is. So 40 peaches per crate, okay? So what's our equation? Well, our direct proportion equation is Y equals K over X. But we know in this case, they gave us a different variable for Y and a different variable for X. So I'm going to change my Y. They want me to use P. My constant is 40. And my X is represented in this problem by C, or the number of crates. So my direct proportion equation would be P equals 40 times C, meaning the total number of peaches is equal to 40 peaches per crate. So 40 times each crate that is packed. And then, so what's the missing values? Well, I can use this formula to help me find the missing values if I would like to. So here we're missing our X, right? But we have our total peaches. So we would plug in our value for P, 1,000 equals 40. We don't know the number of crates, right? So divide 40 by 40, divide 1,000 by 40. $25. So that means that there are 25 crates. 25 crates. And I can double check. If I was taking the algebra placement test, I'd want to double check my work. And how do I do that? Well, hopefully 25, our number of crates, times our constant, 40 peaches per crate, will give us 1,000 peaches total, and it does, so we know we did it correctly. And then the last one, we're still using our same formula. P equals 40 C, but we know our number of crates, so we plug in that value of 56, but we don't know our number of peaches. But if I do 40 times 56, I will get that I have 2,240 peaches. So that I will put up here. Which makes sense if you look at the rest of the chart, right? Because in 25 crates, there were 1,000. We've more than doubled, right, by going to 56. So we know our answer should be more than double than 1,000, which it is. So we did it correctly. All right, you're going to try one on your own. Okay, so we are now on page 271. And of course, they have to throw in percents with direct proportion. So on page, and I would definitely, again, be following along with your book, but solve a direct proportion problem involving percent, okay? So that's the skill we're going for here. So the regular price of a phone, or the full price of a phone, was $228. During a sale, it was marked down by $45.60. Use a proportion to find the percent discount. So you're like, wait a minute, it doesn't use the phrase directly proportional, which is what Mrs. Saber told us to look for. It doesn't have a table with a Y or an X. Like, it doesn't tell me a constant. How do I tackle this problem? So when it's telling you to use a proportion, that's like where we use the equivalent ratios or equivalent fractions to set this up. So what we don't know is the percent discount, right? So this is like our X. This is our unknown. This is what we're searching for, right? We want to know what percentage is this discount if it was marked down by $45.60. What percent discount is happening here? So what we can do is we can start with saying, all right, well, we know the regular price of a phone was $228. So at 100%, right? Because that's meaning it's full original value, right? This is the regular price. The full percent is 100% over $228. What percent represents $45.60? Okay, so 100% reflects the price of $228, right? Because this was a regular price of a phone. So that's where I'm coming up with the 100 here. The regular price of the phone, the full price of the phone is $228. So 100% reflects $228. We want to know what the discount is to show that it was marked down by $45.60. So that doesn't mean that that's what the final price was. This is just what's a percent discount, all right? So at 100%, it's $228. But at what percent discount is $45.60? Then we use that cross products property, where we multiply 100 by $45.60. And we say that that is equal to 228x. Now, if I multiply 100 times $45.60, I get 4,560. 4,560 equals 228x. Now, I want to get rid of my 228, right? Because I want to isolate my variable. So if I divide 4,560, divide that by 228, I get 20. So my answer is that the percent discount is 20%. To find the percent discount, our percent discount was 20%. Now, some of you, probably many of you, will have looked at that problem and said, all right, well, 228, and you're like, all right, well, I know that 2280 is 10%, 2280 is 10% times 2, oh, that's 4560. So without setting it up as a proportion, you probably were able to find out that that was the 20% discount. But what we're trying to get you to stretch and learn something new here is, can you set it up as a percentage, or I'm sorry, as a proportion to find out that same information? So it's kind of like, can you throw more tools in your toolbox to help you with how to tackle a problem? So I'm super psyched if some of you realized how to find the percent discount with the information provided in the question. Like, that's awesome. That's showing me you really understand percents. But I want you to also try to understand this new methodology, which is saying, if I know something at a regular price is 100% is at 228, if I want to find the discount, I can set up a proportion. Remember, percent to percent, dollar to dollar. You have to set up your proportion where your same term is in your numerator, as in the numerator over there, and the denominator in the denominator over there, dollars to dollars, percent to percent. Now you could say, does it matter which one went on top? Let's try that out. If I had $228 over 100%, and I have $45.60 over X, according to the cross product property, does it matter in this case which one was on your numerator, if it was dollars in the numerator or percents in the numerator? And if you look, of course, does it matter? It does not matter in this case. What matters, though, is, as we're doing all the same things here, is that you have to make sure that you're consistent with either putting your percents on the denominator and your dollars in the numerator, or your percents in the numerator and your dollars in the denominator. Because if you don't stay consistent with that, like let's just say that I put 100 for my percent over 228, and then I went and put, instead of for percent, I put my discounted amount there, and I put my X with my dollars, of course that then would get you a different answer, okay? So when you're setting up a proportion, it's less important of which one goes in your numerator in this example and which one goes in your denominator, but you have to be consistent. You have to keep like the units of measure the same, percents to percents, dollar to dollar. Dollar to dollar, percent to percent. So hopefully that makes sense. Try some on your own and let me know if you have any questions.